once in a while, I have the privilege of presenting a fish program on Science in Action. And that's quite fine by me because there is really nothing that I would rather talk about than fishes. Now, on my office door at Steinhardt Aquarium, I have a door sign which has as a background material something that's a little bit different. Notice these sharp teeth that go completely around the outside edge of this saw from a very large, approximate 12 or 13-foot sawfish. Now, those teeth are very, very important to the sawfish because it enables the sawfish to obtain its food. And he uses this saw much in the manner of a two-edged sword, and he swims through a school of fish, slashing sideways so, and those wounded fish are left there, and then he comes around later and picks them up, and of course eats them. Well, now, we do not have a sawfish to show you, but we have the next best thing, a sawfish without a saw. This happens to be the guitar fish. And actually, hold still there, youngster. Now, actually, if we were to attach this saw to the nose of this guitar fish, for all practical purposes, we would have a sawfish. Now, sawfishes and guitar fishes belong to an overall group which includes the sharks, both good and bad, as well as the skates and the rays. Now, there's one thing about these various kinds of fishes, and that is that they have a skeleton which is a bit different from that we are normally accustomed to. For example, here is a bony skeleton of a tropical marine fish, and that is the sort of thing you usually find. But the sharks and their relatives have a cartilage skeleton, and I can demonstrate that more easily by comparing these two skulls. This large one comes from a 40-pound totuava. By contrast with that, here is a skeleton from a 10-pound leopard shark. Now, taking this knife, I could cut for a considerable period of time on this, and I wouldn't have much luck in trying to cut through it. But notice what happens now to this skull from this leopard shark. If they bear down on it, without too much trouble, I go completely through the skull, and it is cut in half, as we see here. So that basically, then, we have two kinds of fishes, one kind of fish that has a bony skeleton, and another kind of fish that has a cartilaginous skeleton. Now, we can point out some of these differences again by means of this model. Now, let's assume that this model is a very primitive fish with a bony skeleton. Notice that the mouth is on the undersurface. Now, the fishes of this type, of course, have an arrangement about as we see here. If we were to change this fish over from a bony fish to a cartilaginous fish, we would have to change first the skeleton. So we'll change it from bone to cartilage, but with this type of a tail, it wouldn't work just too good. So let's modify this tail to make it more effective for a fish that might have a cartilage skeleton. And when we look at the tail of a live leopard shark, we see that it has this same arrangement with the upper lobe being longer than the lower lobe, a sort of a lopsided arrangement. Now, coming back to our fish, let's see what happens now. On a normal fish, the water goes in the mouth and out over the gills and comes out from one opening at the backside of the gill. But if we were to modify this as we find the sharks and their allies, well, then we would have, perhaps for better respiration, a number of gill openings here, usually 5, but occasionally 6 and sometimes 7. And when we examine very carefully the gill area of a live leopard shark, we see that he has 5 gill openings, as we can see here. Now, the relationship of the pectoral fin, that's the fin that we have here. That pectoral fin, or arm fin, is very important in shark classification. So now let's, perhaps for a better type of living than, or a better modification of living, let's change the position of the gills in relation to this fin, move the fin upward and move the gills downward, and also modify that fin so that it becomes quite large. And in so doing, we will put in this expanded fin about in this position as we see here. And then we find that we have a different kind of an animal. Notice what's happened now. On the undersurface right here, we find the gills. In other words, the gills are now below the pectoral fin, whereas before they were above. Now, coming back to the tail, this type of tail would perhaps not be too well adapted to the type of life that a bottom form such as this would have, so let's modify the tail. And we find that now with these two little fins here, we actually have a skate. And when we examine a living skate, we see that we have the same general arrangement. Looking underneath, we see that the gills are underneath the body. There's the mouth, as we can see it, and the animal in this position. Now we can make some other changes, perhaps to modify for a different type of life. Let's take off these two little fins that are here, And let's extend this tail fin out a bit further. And in doing that, we find that we have a long filamentous tail, and so our skate has now become a ray. We can do one additional thing here, which will increase the ability of this animal to survive. We'll add a poison spine at this point. And so this animal then becomes a stingray. And when we examine a living stingray, we can see that at this point is this poison spine. And the poison spine has a poison gland that runs down on the inside of the spine, and also there is some material, poison material embedded in the base of the tail itself, so that if you should happen to step on one of these fellows, it might mean a period of 3 weeks either on crutches or in the hospital. So they can be quite dangerous. Now, one of the other modifications of this pectoral fin, this expanded pectoral fin, is that which we find in the electric ray. And I think I can best demonstrate that first on this chart by pointing out what has happened to the electric ray. He has the same general body plan, but up in here, the muscle has been modified to form electric tissue. Now, you're perfectly safe with one of these fellows as long as you pick them up by the tail. But once you touch this area, then you get quite a jolt. I see Bob has one in the net over here now. I'm going to see if I can catch this fellow and get him out of here without too much of a shock. As long as you have him by the tail, then you're perfectly all right. Now, this is a pretty good fellow, fairly good size. And Bob, if you will put the electrodes down on here, we'll see if we can demonstrate the sort of a charge that he gives off. Now, I should point out that over on the side, we have an oscilloscope and also a voltmeter. And now, as I agitate this fellow and put the 2 electrodes down here, we should see an indication on the, there, the needle swinging over is putting out quite a charge. Maximum on these fellows is said to be somewhere around 350 volts. The amperage is not definitely known, but it is sufficient that if one of these fellows comes in contact with a leopard shark in the tank, and we've seen this happen in the past at Steinhardt Aquarium, the leopard shark will go right up in the air, and he'll come down not in the tank, but over on the floor in the corridor in the back. And we can see these readings as they appear on these instruments. Well, we'll put this fellow back in his tank. Notice I'm holding him again by the tail, very carefully. We'll just scoot him down in here into his tank again. Now, quite often the question comes up, well, now, where do sharks live? How large and how small are they? We brought to the laboratory one of the smaller types of adult sharks that are known. This one happens to be a brown shark, a very deep sea form, very uncommon. And we look at the dental formula, we see that he has a very interesting arrangement as demonstrated here. Not very common because he lives in such deep water. Actually, of course, there are a large number of other sharks that are much larger, and probably the 2 largest sharks are the basking shark, which reaches a length of about 45 feet, and the whale shark, which reaches a length of some 60 feet. Recently, one of our guest scientists of last year, Conrad Limbaugh, had the opportunity of riding on this part of the tail of a big 40-foot basking shark. Using aqualung, he was able to demonstrate the important thing about these big fellows. Although they are the largest sharks, they are still harmless insofar as man is concerned. They feed on the smallest food in the sea. Now, we know that there are larger sharks than this, but they're not alive today. And the reason we know that is because of the fossil record. And in the fossil beds in various parts of the world, teeth of this size are found. Now, no shark today has a tooth that size. But they've been able to reconstruct some of these giants, and they know that they must be, perhaps 90 or 100 feet in length, and that they had mouths that were so large that a person could actually sit in the mouth without any trouble whatsoever, as we see this man demonstrating on a reconstruction which was made in the East. Now, one thing about sharks, regardless of the size, whether they happen to be large or whether they happen to be small, they are very powerful. As we see here, there goes the harpoon in. The harpooner has made contact with the shark. He's pulling him in. He's coming up. In a very few seconds, we'll have an opportunity to see what happens when one of these fellows is brought up on deck and see the amount of strength that these fellows have. There he is on the side of the deck. There goes some of the rigging. Picking up some more rigging, getting down on the deck, picking up some lines. There goes some netting. He's finally stopped when all of that netting is wrapped around him. And there we can see the mouth and see the tremendous dentition that these fellows have. Now, we mentioned a little bit earlier that sharks characteristically have a lopsided tail. In other words, the upper lobe is much longer than the lower lobe. The greatest development of this is found in the thresher shark, of which this is a very good example. The thresher has a tail, the upper lobe of which is usually equivalent to the length of the body. When we look at this fellow, we can see that these fellows must be extremely fast in the water, which they are. They are harmless to man, and surprisingly enough, this is one of the sharks which is very, very good to eat. And quite often they appear in the markets, usually under other names than as thresher shark. This fellow is harmless. Now, if you should ever be out on a tropical reef or in any area with face mask and flippers on and come upon a shark which has a tail like this, then my suggestion to you is get out of the water just as quickly and as fast as you can, because this mark of a nearly symmetrical tail is the mark of the mackerel shark. And of the mackerel sharks which we know, there are quite a number which are very dangerous to man. This one happens to be the true man-eater, or the great white shark. This one is the largest one ever caught by a woman on rod and reel, about 11 feet long and about 450 pounds. Tail modifications, we have other modifications, for example, in teeth. Now, most sharks have teeth which are similar to these. In other words, they're very, very sharp, and they grow continuously from the inside out. The front row of teeth will perhaps be partially broken, and other teeth come up from the back, constantly coming into position. Now, this type of a tooth structure is fine for any fish that has a carnivorous diet and a need to tear food. But that's not so good for some of the shark relatives that have need for grinding food. And so as a result, the skates and the rays have modified their teeth in the form of molar teeth, as we see here. And these molar teeth are very effective in crushing such things as clamshells. These fellows live out on various places on the beds, and they pick up these various kinds of things. Now, there are head modifications in sharks, as for example the hammerhead shark, in which the sides of the head come out in this sort of an arrangement, the eyes out at the end. These fellows are very, very dangerous, and as we see here, they're quite difficult to handle. These fellows have been known to attack humans, and they must be treated with a great deal of care. Now, for other head modifications, Bob Dempster is bringing in a horn shark here, and I'd like to have you see one of the most peculiar faces in a shark. I have to watch out because he has a sharp horn there, but as I hold him up and we look into his face, we see that the peculiar arrangement there, which has led him at times to be called a pig shark. And notice that very peculiar arrangement of the nostrils and also the teeth, a most interesting animal. Now, turning him to the side here, I'd like to also have you see why he's called a horn shark. Now, notice the part here, right at the anterior part of the fin, there's a very sharp horn. You have to be careful when you work with these fellows because that horn sometimes catches you. The horn shark, or sometimes called the pig shark, this is one of the sharks that lays eggs. It is an egg-laying shark. The period of incubation is usually about 8 months. We have had some of those at the aquarium, and we look at these carefully. We see that they have a number of ridges around the side of them. Not quite certain just what those are for, but we think that they have something to do with keeping the egg anchored in one place on the bottom. Now, sharks have this type of an egg, but the skates have another type. Look at the skate egg, and we see that the arrangement is a little bit different. The tendrils on the extensions of the egg enable this egg to attach itself to bits of seaweed so that the egg can remain in one position. Now, 8 days ago at Steinhardt Aquarium, we had laid an egg which is much different from those that we normally see. It's sort of transparent. If we look carefully, we can see the yolk in the center of that egg. Now, that egg was laid by a shark of which I'd like to show you one here. He seems to be all tangled around my line here. I'll just get him out here. But this fellow is the swell shark, and this shark can do what no other shark in the entire world can do. I have to watch out for that mouth because he can be quite dangerous. But this fellow can swell up. He can swell up and take in air. There's no other shark that can do that. I'm going to put this down on the floor, and we have some others coming out of our artificial tank here. We'll just put them down, and we'll watch them as they swell up. Now, I would like to state that this does not hurt the shark. Sharks can stay out of water for a period of time, 15 minutes up to several hours, depending on the species. Now, these fellows are going to swell up. And we're going to come back to them in about another minute after they've taken in their air supply, and we will see what this balloon effect does to them. Biologists as yet have not been able to figure out why they do this or what possible value it has in the life history of the shark. Now, one way that biologists get data on sharks is through shark derbies. And here we see some sharks being brought in at one of the derbies in this area. We have a number of derbies held, for example, at Monterey Bay and Elkhorn Slough. This one happens to be at San Mateo's Coyote Point. Last year, more than 3,000 fishermen participated in this. And after the catch is brought in and weighed, then the biologists go to work and examine as many of the fishes as is possible and obtain as much data as is possible. Over 1,200 sharks we examined at this last derby and obtained data on them. 16 biologists working. Here one of the sharks is being injected, having its circulatory system treated so that it will be able to be studied in the comparative anatomy classes a little bit later. Some of the boats in the background are used by the derby participants and some of the people watching the work as it went on at the derby. All broken down according to categories. Some of them are quite large at the various derbies. Bat stingrays up to 110 pounds. Various other kinds of sharks at other weights and measurements. Now we're back to our swell sharks once again. These fellows have taken in their air supply, so let's pick them up now and put them back into the big tank, and we'll see how they float. Several of them have swelled up there. We'll put them back on the surface. These fellows should remain on the surface usually for a period of anywhere from a few minutes up to several hours. Now they do this by taking air into their stomach. And if anybody could figure out how to burp a shark, probably we could get them to release that air. But as yet, no one's been able to figure that out. As you can see from the earlier demonstration, they have a very good dental arrangement there, and you have to watch their teeth. Well, those are the swell sharks, and you have seen something that can be demonstrated by no other shark in the entire world. Now, this is a cutout, a model, of a fish known as the pilotfish. The pilotfish belongs to the jack and crevalle group. Notice the banded pattern which you see here. These are the fellows that associate with sharks. And they're often found swimming beneath large sharks, and when we watch them, we see that it's quite an interesting relationship. The pilotfish directly beneath the big fellow. Now, the shark will feed on other types of fish the same size in the area, and yet the pilotfish are never bothered. Again, just why that is, no one has been able to figure out. But here we see 6 or 7 of these fellows swimming beneath this large shark, which we see here. Now, one question often comes up, and that is the problem of how to get away from sharks. We've talked about various kinds of shark problems and matters here. Now, this question about getting away from sharks came up, and during the war, and the Air Force and the Navy spent considerable time on it. And they came up with some answers that are very good and very effective. I have here 2 containers. First of all, which contain shark repellents or shark chasers. And we look at these materials as we pour them out into the beaker here. We can see that it is a very, very interesting material. I'll just put a little bit on the surface here because this contains 2 materials. One, a dye, nigrosine dye, about 80%, and the other, a salt, copper acetate, about 20%. Now, the dye is for the purpose of making a person invisible in the water insofar as the shark is concerned, and the salt keeps the shark out of the area. Copper acetate is the one thing that sharks do not like, and so they take off with a tremendous hurry. Suppose now we watch the Navy testing some of these shark repellents. They're throwing in trash fish. One shark's starting to come up, a few others picking up in the same general area. Very quickly, we'll have a large number of them there. Here's another fellow coming in. Here's some more coming in. About 200 in that school there, all feeding on this fish being thrown over from this research vessel. Notice those sharks. See how they feed there. That's one place you wouldn't want to be. That is in the water at this time. Now, the repellent is going overboard. You see that dark color going into the water? They throw in some more fish, and even though the fish is there, it's still safe enough that these 2 people can jump overboard and demonstrate that as long as they remain in the area in which the dye is present, then it's perfectly safe for them to be in the water. And here they are floating out in the water. Notice the dark color, the difference in the color of the water. On the right, the dark color indicates the shark repellent, and the lighter color on the left indicates the area in which it... Now, here comes a shark fin, Navy flyer down in the water. What's he going to do? He pulls out his shark repellent, puts it around in the water, and as long as that shark repellent is around him, entirely over the whole area, then he's perfectly safe. Here he keeps putting it out. Also puts out a marker dye at the same time so that here it goes out underwater. It completely obscures him so that the shark can't see him, and of course the copper acetate keeps the sharks out of that area. Now, we've examined some of the problems in the shark world. There seem to be certain aspects that stand out above others. First of all, these fishes, whether they're small or large, they have a skeleton which is made of cartilage. Usually that cartilage is fairly soft. And they have gill openings which are a little bit different from the normal fishes. For example, here we see the 5 gill openings on this man-eater, or great white shark. And there's also one other point that comes up, and that is this. You often hear quite a bit debunking sharks as being dangerous animals, but there's one thing you can't get around. They are extremely strong. And so wherever you find them, you have to treat them with a considerable amount of respect. Now, I'll be back in just a moment with the animal of the week. We've talked about various kinds of leopards, but this is a kind that is the real thing. These are 9 weeks old leopard cubs. And notice the very beautiful markings that they have here. Our leopard man, Pete Peterson from the San Francisco Zoo, has brought his special charges over. And Pete, I'm wondering now, this one seems to be a little bit frisky, not having been on television before. What do you think is the trouble? Oh, what a beautiful tooth pattern.
Just a little bit nervous.
Well, now, do they always act that way?
No, they've been in this container for quite a little while, and it's kind of got them nervous. They're not generally that nervous, but
well, see,
fine for a while.
About how much do they weigh at the present time?
They weigh about 4 pounds apiece.
I would like very much to handle them, but I know the mother objects to such things, so, it doesn't seem to like me at all. I wonder, maybe if I bring my hand around here, she would face out in this direction, do you suppose? Let's see what they, Now, it seems to me a bit strange that a kitten this young should react that way. Is that characteristic of leopards?
Well, as soon as they start eating meat, they start getting...
they do?
Turning into leopards.
Well, now let's see. These have been on a milk diet up to this time,
yes,
right?
Yes, they started eating meat about a week ago, and then they start getting mean as soon as they have getting the blood and the meat.
Well, now, how much longer can you handle these, do you think?
Well, I think about 3 weeks more will be about the limit, yes.
Well, now that you have picked up the youngster, he seems to be perfectly all right.
Yes,
what is the name of this one, or do you have your name?
This is Punch and Judy.
Oh, Punch and Judy. Which is Punch and which is Judy?
Right now I couldn't tell. We just call them Punch and Judy.
Now, one thing I'm wondering about, what about the rate of growth on these fellows in relationship? Now, full grown, they'll be about what?
They get about, the average weight is about 85 pounds. Some of them go to 125, but the average all the way through is about 85 pounds. And
well, these are really quite nice, and as I say, I would like very much to handle them, but I know their mother would object to that. So, Pete, I do hope that you will keep us advised, and if I can shake your hand here without, if this hand is all right, I hope you'll let us know how these little fellows work out. I know you have another litter from the previous year there, and
yes, I have a nice litter out there.
Keep us informed as to how these work. Now, this piece of equipment is of a type that we will demonstrate and discuss on our coming program. Our special guest at that time will be Mr. Howard Vesper, the Vice President of the Standard Oil Company of California. So if you're interested in oil wells and oil drilling, and I hope that you will plan to be with us at that time. Thanks a lot.
You have just seen another in the fascinating television series, Science in Action. Science in Action is produced by the California Academy of Sciences under the supervision of Dr. Robert C. Miller.